Welcome to the 93rd lecture of Digital Electronics. In this lecture, what you are going to do is, you are going to convert D flip-flop to SR flip-flop, D flip-flop to JK flip-flop, and D flip-flop to T flip-flop. That is what we are having is D flip-flop. It needs to be converted to SR flip-flop. D flip-flop needs to be converted to JK flip-flop, as well as D flip-flop needs to be converted into toggle flip-flop. Okay, so that is the basic idea. Okay, so first one is conversion of D flip-flop to SR flip-flop, or realization of SR flip-flop using D flip-flop. Okay, so that is we can take it in any way. Okay, so what we have is D flip-flop. What we have is D flip-flop. Okay, what is required? Required is SR flip-flop. That means you need to write D as a function of S, R and Qn, as well, and D as a function of S, R and Qn. Only D is there, right? Okay. Now for that, let me draw the truth table of D flip-flop, truth table of SR flip-flop. First of all, let us draw the truth table of SR flip-flop. So having Qn plus 1, S, R, 0 0 0 1, 0 0 0 0 0 0 1, 0 1 0 0 0 1 1 1 0 0 1 0 1 1 1 0, and last is 1 1 1. And if you are taking the decimal equivalence, you will get it as 0 1 2 3 4 5 6 and 7. And we are not going for the don't care combinations of this S and R. Now, what is Qn plus 1? 0 0. So present state, this is present state Qn, next state is Qn plus 1. If S and R is 0, present state will remain as next state. 0 0 1. Now 0 1, it is resetted. That means 0 is resetted to 0. 0 1, it is resetted. So that means 1 is resetted to 0. Now it is set. 1 1 means it is set. That means 0 is set to 1. 1 is also set to 1. 1 1 means 1 1 means if both S and R is equal to 1, we cannot predict to which state it will go. So we can take it as don't care. Now what is the value of D? So what is basically D? D is equal to Qn plus 1. So we can write it as 0 1 0 0 1 1 don't care. Since Qn plus 1 is equal to D, that is there we are getting the excitation table of D. Now you need to write D in terms of S, R and Qn. So I am drawing the K-map. Drawing the K-map. 1, 2, 3. So here what you are having is SR. You need to find D. Right? Yeah. That is, this is Qn as 0 1. This is Qn bar and Qn. So here what you have is Qn. 0 0 0 1 1 1 1 0. S bar, R bar, S bar, R, S R, S R bar, 0, 1, 2, 3, 4, 5, 6 and 7. Now what do you have for 0, 1, 2, 3, 0, 1, 0, 0, 0, 1, 0, 0, 4, 5, 1, 1, 4, 5, 1, 1, 6 and 7, it is don't care. So here what we can do, here you can do in two ways. Right? Here we can do like this. Here you can club these two. First of all, you can club this as a quad. So what will you get? You will get S. Then you can club this one and this one. So clubbing that, what will you get? This is R bar Qn. This R bar Qn. Therefore, we can write the expression for D. sorry, you need to find the expression for S and R, right? Yeah. Sorry, there is a mistake over there. Here. So here what happens is that you need to find S and R. There is a mistake over S and R as a function of D and Qn. That is it. Okay. Sorry, the other one is correct. The other track is correct. Sorry. You need to write D in terms of, that is it. Yeah. You need to write D as a function of D. You need to write D as a function of S, R, and Qn. That is it. Yeah. So here what will we get? D is equal to S or R bar Qn. That is S. Sorry, that is D. D is equal to S or R bar Qn. D is equal to S or R bar Qn. Now, that is the next question. Now, what we are having? We are having a D flip-flop. We have to convert it into SR flip-flop. That is it. Okay. So, you are having a D flip-flop. You are having a D flip-flop. Clock is there. Qn is there. Qn bar is there. S is there, R is there. Yeah. Now, what is D? D is equal to S or R bar Qn, right? S or R bar Qn. So you can write S or R bar Qn. So you can write Qn is here. So here what we get? This is R bar Qn. These two things needs to be odd. Okay. And that is put to D. Okay. And you can take Qn out and Qn bar is taken out. So this is how to realize SR flip-flop using D flip-flop. How to realize SR flip-flop using D flip-flop. Okay. So now I have converted D flip-flop into SR flip-flop. Second one, next one is conversion of D flip-flop to T flip-flop. Or what I can write is a realization of T flip-flop using D flip-flop. So here what we have is D flip-flop. Okay. What is required is T flip-flop. What is required is T flip-flop. That means you need to write D. You need to write D as a function of T and Qn. Right? D as a function of T and Qn. So first of all, let us draw the two tables. So what we have is T and Qn. So for T and Qn, what you should have? So it is, yeah. So you can have 0, 0, 0, 1, 1, 0, and 1, 1. Now what is Qn plus 1 in that case? That is the next state. This is the present state is Qn. Next state is Qn plus 1. In that case, what is D? That is the question. So 0, it will be 0, 0, it will remain there. 1 means 0 will be changed to 1. 1 means 1 will be changed to 0. What is basically D? D is equal to Qn plus 1. So you can write it as 0, 1, 1, 0. Now you need to write D in terms of T and Qn. So it is basically a two variable K map. It is basically a two variable K map. Okay. You write as this is T, this is Qn. 0, 1, T bar, T. 0, 1, Qn bar, Qn. 0, 1, 2, and 3. 0, 0, T 0, 0, 0, T 0, 0, 1, 1, 1, 0, 1, 1, 0, it is 1, 0, it is 1, 1, 1, it is 0, 1 and 1, it is 0. Therefore, what is the expression? So we can write this term is T bar Qn, and this term is TQn bar. So you are going to find the expression of D. So what is D basically? D is equal to TQn bar or T bar Qn. Or you can write D is equal to T XOR Qn. So if you are drawing the figure, it will be like this. You are having a D flip-flop. Input is T. There is a clock there. There is a clock for a D flip-flop. There is Qn bar. What is D? T XOR Qn. So I am having an XOR gate here. Qn is being XORed. And you will get D. Okay. So and Qn is taken out, and Qn bar is also taken out. This is how you are converting D flip-flop into T flip-flop. Okay. So now I have converted D flip-flop to SR flip-flop and D flip-flop to T flip-flop. Now coming into conversion of D flip-flop to JK flip-flop, or in other words, what we can write, realization of JK flip-flop using D flip-flop. Okay. So how to proceed with it? That is the question. So how to proceed with this? What you are having is D flip-flop. What you require is JK flip-flop, right? Okay, so you need to write D as a function of J, K and its Qn. That is, D should be written as a function of J, K and Qn. So first of all, let me draw the truth table of JK. We'll draw the truth table of JK. So we are having J, K, Qn, that is present state, and next state, that is Qn plus 1. Qn plus 1 is next state. Now from there, what we are having? First you need to get D. We are having 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, and last one is 1, 1, 1. So if you are writing the decimal equivalence, you can write it as 0, 1, 2, 3, 4, 5, 6 and 7. Now coming back, okay. It is if J and K and 0, first state will be equal to next state. So that is equal to 0. First state is equal to next state 1. 0, 1 means it is reset. So 0 will be reset to 0, 1 will be reset to 0. 1, 0 means it is set. So 0 will be set to 1, 1 will be set to 1. 1, 1. 1, 1 means if J and K both are equal to 1, it is toggle. So 0 is converted to 1 and 1 is converted to 0. What is D basically? D is equal to Qn plus 1. So you can write 0, 1, 0, 0, 1, 1, 1, 0. Qn plus 1 is equal to D. Now you need to write now next step is you need to derive the D as a function of J, K and Qn. So I am drawing the K map. 1, 2, 3. Here what is this? This is JK, Qn, 0, 1. This is 0, 0, 0, 1, 1, 1, 1, 0. J bar, K bar, J bar, K, JK, J, K bar, Qn bar, Qn, 0, 1, 2, 3, 4, 5, 6 and 7. Now coming into the values. 0, it is 0, 0, 1, 2, 3, it is 0, 1, 0, 0, 0, 1, 0, 0, it is 0, 1, 0, 0, 4, 5, 6, 7, 1, 1, 0, 4, 5, 6, 7. Okay. Now, how to proceed with this case? Now, here we can do in two ways. How to club? Here, how to club means, here we can club these two. If you are clubbing these two, what will you get? J, Q and bar. Now you can club these two elements. If you are clubbing that two, what will you get? Which is common? K bar is common and Qn is common. So it is. So what we can write? Now we can write D is equal to J Qn bar or K bar Qn. Now let me draw the circuit of it. We are having a D flip flop. Qn is there, Qn bar is there, clock that is there. We are having two inputs, J and K. Now what is D? J Qn bar. J Qn bar is AND gate. J Qn bar or K bar Qn. K bar Qn. Now you can bit this OR gate to go to D. Okay. So this is how you are converting D flip flop into JK flip flop. So this is the D flip flop and you are inputting J and K. Okay. So in this lecture what we have done? We have done with conversion of D flip flop to SR flip flop. That is, you will get D is equal to S or R bar Qn. Then D flip flop to T flip flop. That is, here D is equal to T XOR Qn. And last part we have converted D flip flop to JK flip flop. That is, D is equal to J Qn bar or K bar Qn. Okay. So in the next lecture we will be converting T flip flop into the other formats. Thank you.